What if I told you the most impactful volcanic eruptions aren't happening on land but miles beneath the ocean's surface? The Pacific Ring of Fire, a region known for its earthquakes and surface volcanoes, is hiding an unseen force, a silent architect of our planet's future. Deep beneath the waves, a network of underwater volcanoes is reshaping ocean life and altering global climate patterns in ways you can even imagine. For centuries, humanity has focused on the surface eruptions, the ones that shake the land and spew ash into the atmosphere. But beneath the ocean's depths lies a vast and largely unexplored volcanic system that is just as important to the planet's overall health. These underwater eruptions, often invisible to the naked eye, are responsible for some of the most significant geological and environmental changes Earth has experienced, and yet they remain one of the least understood phenomena in modern science. Today, we're diving deep into the mysterious world of underwater volcanic eruptions, exploring how they affect ocean ecosystems, influence global climate patterns, and contribute to the balance of life on Earth. Let us uncover the hidden fires of the Pacific Ring of Fire and understand why these underwater volcanoes are more powerful than we have ever imagined. What exactly are underwater volcanoes, and why are they so difficult to study? These questions lead us into a fascinating and lesser-known area of volcanic science. Underwater volcanoes are much like their land-based counterparts. Magma rises from beneath the Earth's crust, builds up pressure, and erupts. But the major difference is that these eruptions happen beneath the surface of the ocean, often in complete darkness. These eruptions, known as submarine eruptions, can take place at the edges of tectonic plates, in oceanic hotspots, or in the middle of the ocean floor. What sets underwater volcanoes apart from their terrestrial cousins is their environment. The intense pressure of the deep ocean, combined with the freezing cold and darkness, creates an incredibly challenging environment for volcanic activity. Despite these challenges, underwater eruptions are an ongoing and powerful phenomenon, continuously reshaping the ocean floor and, by extension, our planet's surface. One of the reasons these volcanoes remain so elusive is because they are hidden deep below the water's surface. Unlike surface volcanoes that can be studied up close, scientists must use remote sensing technologies, submersibles, and underwater drones to observe and monitor these eruptions. The vastness of the ocean, the difficulty of accessing remote regions, and the cost of conducting deep-sea research make these volcanoes much harder to study than land-based eruptions. Additionally, underwater eruptions often occur in isolated and difficult-to-reach locations, far from established research stations. This leaves much of the Pacific Ring of Fire's submerged network largely unexplored. While researchers have been able to monitor certain eruptions, there are still many mysteries surrounding how these eruptions occur, how frequently they happen, and what their long-term effects on the planet's climate and ecosystems truly are. The Pacific Ring of Fire is one of Earth's most active and well-known geological regions. Stretching around the Pacific Ocean, this area is home to approximately 75% of the world's active volcanoes and 90% of the world's earthquakes. Most of the focus on the Ring of Fire is placed on the surface eruptions that impact land masses and local populations. However, what many people don't realize is that beneath the waves, a far larger network of underwater volcanoes is quietly exerting its influence. The Pacific Ring of Fire is not just a series of eruptions on land. It is also an intricate and dynamic network of underwater volcanoes stretching across the ocean floor. These submerged volcanoes are scattered along the tectonic plate boundaries that make up the Ring of Fire. The tectonic activity in this region causes massive movements in the Earth's crust, creating areas of intense volcanic activity beneath the ocean's surface. Submarine volcanoes play a key role in the Earth's geological processes. They contribute to the formation of new oceanic crust, releasing vast amounts of heat and minerals into the surrounding water. The minerals and chemicals expelled by these underwater eruptions are essential for sustaining marine life, influencing ocean chemistry, and contributing to the delicate balance of the ocean ecosystem. Some of the most active underwater volcanoes are located along the oceanic ridges that mark the boundaries between tectonic plates. One of the most famous and well-studied areas is the Mid-Ocean Ridge, a vast underwater mountain range that spans thousands of miles across the Pacific Ocean. This ridge is dotted with hundreds of volcanic vents and is responsible for the continual creation of new oceanic crust. At certain points along the Pacific Ring of Fire, the plates are slowly moving away from each other, allowing magma to rise from the mantle and form new crust. As the magma cools and solidifies, it creates new seabed, altering the shape of the ocean floor and contributing to the expansion of oceanic space. These volcanoes may be invisible from the surface, but their impact is profound, affecting the entire geological structure of the Earth's oceans. Understanding underwater volcanic activity presents significant challenges, particularly in the context of the Pacific Ring of Fire. The sheer scale of the ocean, combined with the depth of these volcanoes, makes it incredibly difficult for researchers to monitor these eruptions in real time. Despite technological advancements, we still face significant limitations in our ability to study the full extent of submarine volcanic activity. One of the biggest challenges lies in the vastness of the ocean. The area of the Pacific Ring of Fire that is submerged is enormous, stretching across thousands of miles of ocean floor. Only a small fraction of this area has been explored in detail, and even fewer regions have been studied for underwater volcanic activity. The technology required to study these volcanoes, such as deep-sea submersibles and remote-operated vehicles, ROVs, is expensive and requires specialized equipment. Furthermore, the lack of direct observation means that much of our knowledge is based on indirect measurements. Researchers rely on seismic data, underwater sensors, and satellite imagery to monitor volcanic activity. Seismographs placed on the ocean floor can detect tremors caused by the movement of magma, but these signals are often faint and difficult to interpret. Even with the use of advanced sensors and drones, direct observation of eruptions is still rare, meaning we often lack a complete understanding of the dynamics of these volcanoes. Another limitation is the challenge of studying the long-term effects of underwater eruptions. Because these eruptions occur far beneath the surface, it is difficult to track their evolution over time. The sheer scale and isolation of these underwater volcanoes mean that data is often collected from single events, rather than over long periods, leaving gaps in our understanding of their long-term impacts. Despite these challenges, there is still much to learn from the underwater volcanoes of the Pacific Ring of Fire. Advances in remote sensing technology, better seismic monitoring systems, and the development of autonomous underwater vehicles are helping scientists gather more data and monitor these volcanoes more closely than ever before. Underwater volcanic eruptions are not just geological events. They also have a profound impact on ocean ecosystems. These eruptions release heat, minerals, and gases into the surrounding water, creating conditions that can either sustain or disrupt marine life, depending on the nature of the eruption. When magma rises from beneath the ocean floor and interacts with the seawater, it releases chemicals such as sulfur, carbon dioxide, and other gases. These gases can create toxic environments around the eruption site, harming marine organisms that rely on stable conditions for survival. For example, increased levels of sulfur can acidify the water, which has detrimental effects on coral reefs and other marine species that depend on a stable pH level to thrive. On the other hand, volcanic eruptions can also contribute to marine life by providing a rich source of minerals and nutrients. The minerals released by underwater volcanoes, such as iron, magnesium, and silica, are crucial for the growth of certain marine species, particularly plankton. These microscopic organisms are the foundation of the ocean food chain, supporting everything from small fish to the largest whales. The hot hydrothermal vents created by underwater eruptions are also home to unique ecosystems. These vents, where superheated water escapes from the Earth's crust, create environments that are teeming with life, even in the absence of sunlight. Species such as tube worms, shrimp, and crabs thrive in these extreme conditions, forming complex communities that are unique to these volcanic environments. However, the unpredictability of underwater eruptions poses a significant risk to these ecosystems. Large-scale eruptions can cause mass die-offs of marine life, while smaller eruptions can have localized impacts that disrupt food chains and biodiversity. The effects of these eruptions on ocean ecosystems are not fully understood, but ongoing research is shedding light on how these volcanic events shape marine life. In addition to their impact on local ecosystems, underwater volcanic eruptions can influence global climate patterns. While surface eruptions are often the cause of short-term climate cooling due to the ash and sulfur dioxide released into the atmosphere, underwater eruptions affect the climate in a different way. One of the most significant impacts of underwater volcanic activity is the release of carbon dioxide, CO2. As magma erupts beneath the ocean, it can release vast amounts of CO2 into the water, which is then absorbed into the atmosphere. This release of greenhouse gases contributes to global warming, as CO2 is a major driver of climate change. Moreover, the heat released by underwater volcanoes can affect ocean circulation patterns. The warming of deep ocean waters due to volcanic activity can alter the flow of ocean currents, which play a crucial role in regulating the planet's climate. Changes in ocean circulation can influence weather patterns, affect the distribution of heat across the planet, and even contribute to changes in precipitation and storm patterns. Though the overall contribution of underwater volcanoes to global climate change is still not fully understood, it's clear that they play a significant role in regulating Earth's climate system. Scientists are continuing to study how these volcanoes contribute to long-term climate variability and how their activity may interact with other natural and human-induced climate forces. As we've seen, the underwater volcanoes of the Pacific Ring of Fire are powerful forces that shape not only the ocean floor but the global environment as well. From the creation of new landforms to the release of gases and minerals that sustain ocean life, these submerged giants are a vital part of Earth's geological and ecological systems. While studying these deep-sea volcanoes remains challenging, advances in technology are helping us unlock the mysteries of this unseen world. As we continue to learn more about how these eruptions impact ocean ecosystems, global climate, and the very shape of our planet, we will gain a deeper understanding of the forces that shape the Earth beneath the waves. The Pacific Ring of Fire's hidden volcanic world may remain largely invisible, but its impact is far-reaching. By uncovering the secrets of these underwater eruptions, we can better prepare for the changes they bring and ensure that we understand the profound role they play in the future of our planet.